is me, Vishwas Nair. I'm the host of this podcast, and Parth Agrawal is one of my most desired guests. As soon as he gave out that one disclaimer on his slide, I was like, I need him on my podcast. And that's the harsh reality of being a deep learning specialist or a person who is going behind that industry. Like, you need to know what is the pains and the gains of moving to that industry as well. I don't think so. There is a better place and a better time than this to move to the world of deep learning. But to me, I feel that right way of education, the right way of connecting with people probably is going to help you a lot of times educating people thinking about what should be learned in the industry, probably that's the biggest issue, and we are going to address it today and make sure that you learn everything that Parth shares from his LinkedIn, Twitter, anywhere. Like, one of the best people to listen to and reach out to in the social media, and I was lucky that I have done a webinar with him. And thank you so much, Parth. It means a lot when you're on my podcast.
Yeah, thanks a lot, Vishwas, for having me. Nair, I'm not that old. I still started my journey like 5 years
Yeah,
ago only, so I'm not that old.
not that
But
old.
yeah, today the generation moves so fast that you feel old, even though you might still be out of college, or like you might just be like 2-3 years in your job. You still feel old, and
Hmm.
it's probably okay because like the current pace at which technology, especially the domain of data science and AI, which is moving, it makes you feel redundant. And that is why like it's important to like understand what works for you, what you like to do, and practically what is currently going on. So like unless and until you understand the trend, it becomes very problematic to like jump onto the wagon, right? So AI started as a hype back in the 90s. It again died down because of hardware, because of things which accelerated AI again back in 2013, 2014. Now we are in this golden age of AI. So you never know, it might again go away. So unless and until you are there, you understand the core crux of what it is trying to solve, you still might find yourself going away from it sooner rather than later. So yeah, and it's important to have these kind of discussions as well, because you hear these terms like data scientist is the best sought out role of 21st century and all those things. And it's true in part ways because the level of strategies which people are coming up with, especially for like implementing AI, implementing data science in their traditional workflows, is fascinating. And at the same time, it's phenomenal that some companies have achieved a lot because of that. So it does make sense to like be at the forefront of innovation, but at the same time, not everyone is doing it, and
Sure.
it's not everyone's cup of tea as well, right? So you have to make a call. Like one of the most common question which I have come across is that, hey, I am a software tester, hey, I am in mechanical engineer, hey, I'm in this different domain, and I want to switch to data science, or like I want to do data science, I want to do data analysis, I want to be a machine learning engineer. What are the prerequisites? How do I do it? So my counter question always is that why do you want to do it in the first place? What is your motivation? Is it just the herd mentality, or have you actually researched that what is actually going on in the field and what like interests you into like moving into this field? So that is where like people realize that okay, we should do some research before just blindly going into a field, or like just blindly asking people that hey, I want to move to this just because
Sure.
someone told them that hey, go into data science. uh, that is important, right? Because once you're out of college, there is no one practically to guide you. uh, in college you do have your peers, you do have professors, you do have your family also, who treat you like a kid only, that hey, it's fine to make mistakes. But once you are out there in the world, it's difficult, because if you keep making mistakes, no one will be there to like back you up. So it's important to like ask the right questions and not just keep on like going from one place to one other place when someone says that okay, this is the best thing to
This is
do.
the best.
So you should definitely form your own opinions. You should definitely understand what are your strengths and what do you actually like have that what I would say. So people primarily say that you should do what you love and then money flows. But sometimes that also doesn't work. Sometimes you have to just work hard to get to that stage. If money is your only like driving force. So, and that is also fine. I would say that it's not bad that you are doing something which you don't love, but you are getting to your end goal. It is not sustainable for sure, but then it makes sense because your goals and my goals and someone else's goals will always be different. So it should always be an introspection rather than like just listening to people uh, or like seeing LinkedIn updates or their Instagram posts and everything and feel that fear of missing out. That shouldn't be your driving force for such major decisions.
That's true. So let's just start with this philosophical question like, how would human perception change in this decade when there's AI and AGI coming? Because you said that, okay, AI is not an hype, it's a buzzword. To some extent, yes, it's a buzzword. Like, how would perception of human change towards when we are seeing an AGI and an AI system being built in the world today? Like, how is it going to be perceived in this decade?
Yeah, so I think AI has evolved since 1950s, since Alan Turing first started with that paper. Uh, People still didn't believe machines were capable of such things. So I would say the perception always is driven by what we see in the media and not by what is actually happening on the ground. So let's say if someone covers a walking robo and that is talking, that is doing your daily tasks, you feel that this is AGI. This is like the replication of what human means. But at the end of the day, you don't understand that it is just optics. It is nothing else. On the under the hood, it's more complicated to solve for generic things, and that's what AGI stands for. Like you have general intelligence, and general intelligence is very tough to crack. And for this next decade, I'll still say that we will still be exploring narrow AI use cases. We won't get into a general level intelligence because it's very tough. It's the way our human brain works, how some of the things which we do, they still can't be justified. And there isn't a crude mathematical way or like a very theoretical way in which we can define some of this phenomenon. And AI or machine learning works on like those kind of principles only. It's not that whatever you feel that will get replicated by a machine. You have to convert it to the technicalities. So I still believe this particular decade will uh, be more productive for the whole field, but still AGI will still remain as a optics only for certain people to like raise funding or certain people to boast that hey, this thing we have built is here. So just to give you an example, like back in 2016, self-driving car just became the biggest thing, and everyone was saying that by like 2020 we will have self-driving cars on roads. People also came up with flying taxis and drones and everything, right? So people were like, we will have automated deliveries, we will have your taxis which are running automated, and practically that will become the biggest industry. And still, like in 2021, we haven't achieved that. So the estimates are always optimistic, but the ground level truths are always far from it. So, especially in this decade, I believe we will still try to work more towards assistive AI. So, like systems which are more of a guiding nature, where they tell us, AI systems tell us that, okay, this is a particular decision you should take, or like this is something which you can do. At the end of it, you will keep human in the loop in most of the cases. And that is how like the systems will also evolve and we will also adapt to the technology because again to replace a human is problematic in very different ways. First is the adoption. So people don't really, when they are excited about AGI, they at the end of the day they do have that fear also that somewhere down the line they will get replaced. So always there will be a conflict. So whenever there is a conflict, there will always be two parts, like one who would be against it, one would be for it. So it really depends on how much research goes into it and how much people try to figure out a way to like find that balance. So this decade will be more or less like finding that right balance. And then probably if a breakthrough occurs, uh, the most of the decade or like most of the part will go around like how do you package it? How do you make that human connection that it accepts that okay, we are in that state where AI has evolved to such a great extent.
Yeah, speaking of sustainable AI, because like we still are yet to find a solution there. So now we have seen a lot of advancement, and there is an hype about explainable, sustainable AI, which we are trying to go towards. Like, hey, this model failed because this algorithm had only this much amount of potential. So this is how we are
Yep.
moving towards. And automobile frameworks are coming up with like enormous improvement. Like to be very frank, I feel that we are moving somewhere a low code, no code, somewhere towards a sustainable AI. And algorithms today are also very, very human like, because there is a human bias kind of a thing which is being explored. Of course, I feel that we have not yet explored the complete brain, how it works, how it thinks,
Yep.
but yet we are just trying to mimic a brain on a burning box. That's kind of a foolishness, but yet that's the need of the hour today. Like, can we understand this by building such kind of a system? So what is it all about when you're thinking about sustainable AI today, and what is it going to be in the form factor of, like, is it going to be an algorithm, is it going to be in a hardware, is it going to be a software? What is it all about when we are considering what should be the form factor of a sustainable AI for the tomorrow's world?
So there are two things. One is your sustainability and one is your explainability. So when you say sustainable AI, so there are many parts to it. It always depends on who is building it. So let's say if I'm a manufacturing company and I am making lots and lots of different auto parts for that matter. And if like I can solve a certain problem or like a certain defect, it helps in like reducing your accidents, let's say by 10% a year. So for that particular thing, if even if you try to build very large models, even if you throw tons of money behind solving that problem, or like you use up too much compute, that's also fine because at the end of the day, you are comparing it with human lives. So sustainability is more or less they're defined also on cost versus your actual output, whatever you are striving for. So let's say if you are just building a simple model or like you want to build a system which is best at poker, let's say, its aim is to beat everyone every time. And although it's a great system to build, it's probably uh, like useful also to people who want to make money. But the end goal is just to make money. It is not advancing any human life in general, or it is not that impactful. So that is the case. Like sustainability in terms of your output is what drives you towards how you like build the whole process. Versus there is also this growing sense in the community that everyone is learning AI, everyone is building these large models, right? Every year you see researchers trying to break the state of the art benchmarks by just 0.1% or something. And during that process, they end up wasting a lot of compute, which again impacts to global warming and climate change. So that is something which is also needed, that uh, even the research community needs to understand that that 0.1% increment is not worth the effort which they are putting in. and that rat race of them getting published, and like even getting accepted just because they beat the state of the art, that is also wrong. That you There is no uh, generalizability, that okay, this thing has potential, let's keep on exploring more options which are more diverse. They are not the same thing which on which we are building and wasting the same resources again and again. So that carbon footprint which all these training and all these inference models are putting on, uh, that is again something which will become a problem sooner rather than later. So whatever happened with Bitcoin and your GPU mining and all, similar things will happen in these kind of scenarios as well, because you hear your GPT-3s and transformer models, which are billions of parameters and massive in size, and it takes them like months to train them on like high compute clusters. So what it does is, as a small company or as a small startup or a person with a small idea, you can never compete with them because you don't have access to that level of hardware. Second, the other companies who also want to say that okay, we are in the also the same space, they will also try to compete by training their model on a larger machine or like make more bigger models and keep on training it. So that competition is not sustainable in the field of AI, because at the end of it, if you keep on trying to like just look at expanding and using that compute, whereas that compute can be used in somewhere else, or try to optimize the existing systems, uh, that is much more, I would say, desirable, but people don't do it. So sustainability is tricky because people don't value compute right now. People don't value the cost it takes. But more or less, it has to become like your natural oil or something. If you treat it as a resource, which will keep on getting depleted, then only you will realize that, okay, you have limited compute, you have limited resources, and you have to achieve something. So unless and until that constraint is put, I don't think people will ever care about like having it as a sustainable solution versus the explainability bit. So that has recently only come up because like if you're using AI in fields where you need to understand why the model is taking a certain decision, you can't just chalk it up to saying that hey, it's a black box model, we also don't know what is going on. uh, in some cases, especially in healthcare and others, you can't say that I have diagnosed you with so and so disease because a black box model told me. Like if someone told you that, you would never believe it. So because of these cases, people realize that it's important that these models also can be explored in certain ways. So you have various methods by which you can try to figure out why a certain inference is working or why this particular pattern was observed by the model and given a certain weightage. So people are trying to like look into de-jargonizing that black box, and it's important because at the end of the day, unless and until we realize how the model is working, we wouldn't be able to figure out the next stage, which is to actually build systems on top of those patterns or on top of those uh, findings. And that is actually the next step to like understanding how these neural networks work, because that is more or less replicating how our neurons work. So if we figure out that thing, it will definitely help. But again, it's a very complex problem. Not everything can be explained. So that is why people do try to bring a blend of your explainable models versus your traditional models and have some rule based models. So you try to use AI or your machine learning models as a smaller component of the whole larger system. So back in the days, like your traditional AI used to be called expert systems. So it was called expert system because it used to rely on your proper uh, you would have all your databases, you will have all your rules. It was very concise, and you had your knowledge graphs. So you would know why this is happening, or like this pattern was feeded into the system. That's why it is doing certain things. Whereas when you totally rely on data, you inherently don't know that some of the other type of biases also come in. So when you mentioned human bias, so like as a species, sometimes we have evolved in certain cases that we also don't realize that this is a bias, right? So the biggest example is that in natural language processing, whenever you have like these pairs, so when they say king, or like it is supposed to be a man, and if you say queen, it is supposed to be a woman. So based on that logic, whenever you see a doctor, most of the cases in model, it comes up as a man rather than a woman. And whenever you see a nurse, most of the time it comes up as a woman. So those are also natural things which we observe. So the model is just trying to replicate what we have observed over time. So unless and until we try to debias the whole world, the model will also not do the same, because it's just learning from us. The term artificial intelligence is also that only. It is trying to replicate what we do. It is not better than us. It is what we do as a person. So if we are flawed, those models will be flawed, and you have to accept that. Because if by chance your models become better than human, uh, there will be other type of consequences. But at the same time, it is important for systems to learn from the mistakes which we do. So that's why like explainability becomes important, because sometimes you can justify that, okay, a human also behaves in a similar manner, versus sometimes you can say, okay, we also don't know why this pattern came up. So some analysis tells you that, okay, this is the right way. So yeah, these are actually the two fields which might become important as more and more applications come out, because still right now there is not much applied AI which is out there in the world, especially in different fields. So there are always early adopters, and I would say like we still don't have that much adoption in certain fields like logistics, like even in healthcare in certain sectors. People are very skeptic of using these systems because they still want to rely on the traditional ones, which can be explained, which can be trusted, right? That trust factor only comes when your system is too evolved and it is too foolproof, so that people can say that, okay, whatever decision this particular algorithm is taking, that is like God's truth. You can't question it. And that is the stage which is again tricky, right? Because it's all very domain specific. You can't have one system which works for everything and anything. So yeah, these two fields are there to stay. But again, these are very niche fields right now, especially in the AI, and very less research is going on in these fields. Whereas people are more interested towards systems like AutoML and those kind of systems, which are again doing brute force approaches, just leveraging compute, because we don't have uh, we do have unlimited supply of compute right now. So people are happy building like those kind of systems, so that we can explore, we can actually find which algorithm is the best. So unless and until we do specify that, okay, this is the best algorithm for this particular case, we won't stop abusing compute or storage or those sorts of things.
Recently I met a guy from FMS Delhi who's an who's one of the best MBA guys that I met actually. But he still is behind, like every product needs to have an AI and ML. And once I showed him the code, he thought like, okay, this much is the AI and ML. I'm like, no, boss, production mein itna bucks milte hai na. Like you will be like 1800 bucks milte hai. Then
Right.
you'll be like shocked. like what might happen between one TensorFlow version to the other TensorFlow version.
Yeah.
So now we saw that paradigm shift that industry is giving to us today, like something like everybody wants to get inside that industry and everybody wants to be a part of that world. Like today, everybody knows something about it. Like I made a guy who is a Scrum Master come and talk about GANs and some sort of a philosophy, and he was pretty happy that he was able to understand something about it. And it was
Right.
a mimic that he just got to know that, like we are now trying to mimic a biological system that
Yeah.
can make a decision as a machine which can now make a decision. So now what goes behind it is the pure abstraction of frameworks. PyTorch, Kefi is old, by the way, nobody uses it. TensorFlow, JavaScript, TensorFlow JS, so on. So how do you feel that the frameworks and the artifacts which are coming out in the world of AI improving over a course of time? Because lately I've realized that these are not the golden standard that we had, but I feel that they're here to make our lives easier, because whatever 15 years ago Stanford and the MIT guys used to do, we are now able to do with a little bit of an API calls and things like that. So how are these frameworks and the artifacts in the industry improving according to you? Because lately I've seen a lot of changes which came up here, but like what's your experience in all these frameworks?
Yeah, they have made our lives easier. Definitely they have. So I'll just give you an example. So back in 2013 or 14, uh, in computer science, you would practically told or like taught to write these functions for matrix multiplication, to write your vanilla artificial neural networks, you would write your gradient descents and everything. And those would run into lines and lines of code. And it was difficult to build like a neural network code itself rather than like spending time on feature engineering and other things which have now become important. So at that time, people realized, and I think how TensorFlow came into existence, uh, that was also a good example of why companies should open source stuff. That it itself changed the game. That people, when they used to write, when they used to say that, oh, you want to build a neural network, they used to get scared because again, you would have to deal with hundreds and lines of code. You will have to write it, maintain it. The model itself, the coding of the model itself was a bit complicated. So people are always worried that, okay, to get into this field, it's difficult because you need to understand a lot of code. So what these frameworks did was that they like brought this layer of abstraction to the whole coding world. And right now, like not only in AI, but in other fields, there is a no code revolution going, right? So everyone is like, if you want to build a website, you can, even if you don't know programming, you can build it. You can build your whole systems without knowing actually to code. So similar thing was triggered by these kind of frameworks, that even if you don't understand the fundamentals of programming, even if you don't understand the math behind it, you can still use it if you have a use case in mind, if you have the data, you can still use it and it's not that difficult. So it definitely made that, you would say, entry level easier for people to get into AI, and that was its purpose, and it served its purpose. So you had your 2015s and 16s driven by TensorFlow, then you had your PyTorch, you had your old frameworks also, so MATLAB and all the uh, things which is there. So they were used in the academia. They never saw the light of day in production because they weren't made keeping production in mind. Because AI was still considered as a research topic. It wasn't considered as a like something you will have in production running someday. So that perception changed because of these frameworks. And it was a good thing for the whole ecosystem because people realized that you need to write production level code to actually take these systems to daylight, because unless and until people start using it, you won't realize the true potential. So it's good that now people are focused more towards MLOps. People have now focused more towards building better packages, supporting these frameworks in best possible way to suit production level. And I think at least for a couple of more years, you would see a hell lot of development in this space because I think like recently only I was reading about some of the companies like Weights and Biases and Snorkel and other things which are just building tools and software packages to make your production code like to maintain your production code, to understand what the model is doing, just simple analytical stuff. But at the same time, it is super helpful for people who want to put stuff in production, right? So, and everyone is like, you can't keep on researching for years and not have something out there. So you will see a lot more of these come out, uh, even by smaller companies. So that is where like this will get interesting. So you will have even bigger startups come up in this space, who will just try to be the next TensorFlow or be the next PyTorch, and they might also be valued greatly because if they help in like making your life easier in production, they will also work. And and it's important also, right? Like there is always a discussion of language. So everyone discusses why C++, why Python, why Java. So these are like age-old discussions. So even with frameworks, this will remain that why should I use TensorFlow versus PyTorch? Why should I do this versus that? Uh, but I would say that at the end of your observations lies that truth that some things are made keeping certain things in mind. So TensorFlow, when it was made, it was kept in mind that developers will use it. Developers, software engineers who have an inkling towards machine learning will be able to write clean code and use machine learning in their day-to-day lives. So it in the iterations which came for TensorFlow, you had TensorFlow JS, you had TensorFlow Lite, you had all these ecosystem which were built around all the different developer platforms. So it was never in that sense a machine learning library of sorts. It was always meant for developers to leverage machine learning. So with that goal, it always expanded in that directory versus PyTorch, which was more driven towards making research better, making people write efficient code to write custom things and understand custom things. So you will always have newer frameworks which will be very targeted to a certain case. So like there might be some which come up specifically for your deployments, and those frameworks might work well as well. So I think again, there will be lots and lots of frameworks, and there will be a ton of competition in the space, but it just depends on which has a better community and which has a proper goal set that this framework wants to achieve this thing. So unless people align to that goal, that framework would also not work. So you have examples of Cafe, you have example of MATLAB. They have a very niche uh, community, and it has not driven that much as well. So those frameworks die down over time. Those don't evolve. So again, community, especially in open source softwares or packages, is crucial. So and luckily TensorFlow and all these other platforms, the frameworks have a very thriving community because people feel that it empowered them to use AI. So they always feel to give back to the community by contributing in some way or another. And that also helps in like having a community driven development. And this whole AI boom has happened just because of that. Uh, People writing open source code, people open sourcing their work. You have research papers published, and people now publish their code as well. So these frameworks make it easier for them to like code much faster and put it out in the public. And that code can be directly ingested in your production pipelines because you have written in the same framework. So it makes that production from research to production time less, and it's a win-win for everyone. So these like frameworks are probably here to stay. They might get deprecated over time because like as you said, like the versions keep on changing very drastically. and they are still very much breaking changes. So even the content which you get out there for a particular version, teaching you TensorFlow, let's say in TensorFlow 1, becomes outdated in 6 months, because even inside that version, that now the code has changed a lot and it's breaking everything. So on a software perspective, on your traditional software development, it's still not standardized, because the field is also evolving at that stage. But over time, these frameworks will become stable, and the newer frameworks, or the newer uh, people who get into writing these libraries, will also figure out that we need to have like a very standardized way to take it forward. Else it will always be a mess. And yeah, that is, I think, how like frameworks will be in this field.
Yeah, it's really changing. Like literally, like every time you have a new assignment from Coursera, it changes.
Yep.
Like get to know that traction of way in which we are perceiving tech. Everybody has to know the math behind that neural network. Everybody needs to know what goes behind it, because abstraction of those APIs might start changing over the course of time, but yet the math behind it is still going to be the same. Let's say TensorFlow becomes obsolete. You can't say that my TensorFlow was completely shut down because my production didn't have that sort of inversion or things like that. So of course it will be archived and the things like that. So you need to just get that version of TensorFlow or the PyTorch or anything in your production installed, force install it. So that's it all about. So now, you have also worked on academia as well, because you're a part of Udemy and deep learning.ai programs as well. So you see a lot of students, so you see a lot of professions, you see a lot of researchers. So on a scale of 1 to 10, how much is that learning that going behind the AI that we are going to be built by us is effective? Because on a scale of 1 to 10, because I feel that we have not yet reached the perfection of explaining what a neural network is to any
Right.
person. Like it all ends with a black box explanation itself at the
Yeah.
end of the day. System design comes in, this, that, feedback loop, so on. So what is your perception towards the way we are educating people and the way we are getting educated? Because the content is also like that, because that's what we are all about. So if somebody says, hey, TensorFlow gives you a good job, just go start learning. And that's the perception today. So what is it all about when you think about the ways in which people are educated in the field?
Yeah, so I would say we have
Definitely.
evolved in teaching what these neural networks do. So you have so much content out there, which is like really top notch. So not just on like your edtech platforms, but also on YouTube. If you go and search, you'd find phenomenal content creators who have like broke down certain topics in a very easy and digestible manner. That it's out like I don't think people would get confused now that what a neural network does, what is gradient descent, and what is the math behind it. I think people are now much more ahead of that, but there are still gaps in like your advanced content. So there is lots of content which is out there for beginners, for intermediate level, and even the content creators keep on building those, because at the end of the day, they also want more numbers, right? They also want more enrollments. That's a business. So it makes sense to target a wider audience versus like a very niche audience. So when you have topics like your cloud deployments or these kind of things, or even complex topics like reinforcement learning, and even in computer vision, very specific topics, you'd find that it's difficult to get to a proper content form. It might be a blog, it might be a documentation of some code, it might be some video tutorial made by an ex person uh, who is making some other system, but that particular thing which he or she teaches is very relevant. So, in a way, for advanced content, we still haven't figured out a proper way, or I would say, we it's difficult to teach which like penetrates right into the mind. because those are complex topics, right? So at the end of the day, not everyone will get it. So once you are making a content around it, it is also difficult because you have to try to break it down into as much simplicity as possible. And while you are teaching it, you also should be through and through with what the content is. And it is difficult and it takes a lot of time. So when you see these videos or courses which are out there, these are not things which have been done in a day or even month. Sometimes they take years on, like, even in terms of production, in terms of like iterations which it has been through. Sometimes it might even take years to reach to a particular stage. And that is why you have very much quality content which comes out even from your Stanfords, your MITs, your open courseware, because those guys have been teaching the same thing for probably a decade, and they have refined how they teach that particular topic to such an extent that it comes naturally to them. Versus if you start teaching, if you have learned something and if you start teaching it, it will always be different. So I would say we have still more to do in how we teach AI, how we teach stuff. And I think we are at a solid 7 right now. There is still a lot of improvement, but definitely with more and more people getting involved in teaching, especially and having access to platforms like YouTube, it makes everyone's lives easier, right? It's easy to put out content, it's easy to consume content. So you do get supply and demand in abundance. But to get that quality content and like having that curation, that is what is the next step. That how do you identify which content is best for you? So that comes to the second question which you asked, that do we learn the right thing on a scale of 1 to 10? Do we consume the information in the right way? And I would say there we are still lacking, because as I said previously, right, people come from different domains, so the prerequisite level for certain topics, uh, those are very vast at times, and people don't realize that, okay, if even if you learn linear algebra for that matter, you should also have a strong sense of statistics. And if you don't understand statistics, uh, you might not understand some components, and you might just learn it halfway and then go on doing your regular thing, which is also wrong, because at the end of the day it is a combination of certain skills or certain topics which drives that particular field forward. So I would say in consuming information and working on it, uh, we are still behind, because those things are not driven by actual application. So you can see videos, you can read research papers, but unless and until you are applying those things, you don't actually get to learn. So you would have all the certificates in the world, you would have everything. You might have finished your workshops and whatnot, but that retention of knowledge is very, very low in today's world, because these topics require you to like have like a repetitive learning, and that only comes if you are doing that thing on a regular basis or working on that thing on a regular basis. So I think that component is missing still from our learning style. So everyone has a shallow knowledge of how things work, but it takes a lot of time and effort to get into the depth of it. So, and no platform is providing you that kind of thing, that, hey, go practice this particular thing. It's not like a mathematical exercise or a textbook that, hey, you have 10 questions, go solve it. No one is trying to do that, because if someone does that, the retention will definitely increase. Because if you do these kind of challenges of like 100 days of ML and all these things, you're still jumping around topics. It's not like 100 days, just do back propagation. If you do that one thing for 100 days, you would definitely be much, much more better in that particular thing than anyone else in the world. So it's again like that same thing that I think there is that saying that I'm not afraid of you knowing 10,000 moves, which you have practiced just once. I'm afraid of that one move which you have practiced 10,000 times, because that is more important, especially in a field of AI or like data science, where you have innumerable things, right? And innumerable different fields. Uh, you can become a generalist, and generalists. So I am myself, I'm a generalist. So it helps in figuring out that what fits where. But beyond that, you can't go in and actually optimize these systems. So then you become sort of like people who can go in, uh, understand a problem statement, say that, okay, this can be a potential solution. But beyond that step, a specialist has to come in for that particular field and they have to drive it. So it really depends that you want to be a generalist or a specialist. And to become a specialist, you need to understand these things. You need to go beyond the lecture videos, the research papers, and do your own repetitive learning. And that's the only way our mind also functions. That unless and until we keep on revising stuff, uh, unless you are like born prodigy or you understand things much quicker, uh, it's always difficult to like retain information, especially in this field, which gets complex in no time.
I have seen a lot of talks from Andrew Vinci, and he has a sheet of paper which will have all sort of an formulas and things like that. Even if you read his PhD thesis, it's based on the reinforcement learning itself. So when you read all that, you feel that nobody is an expert in the field here. Everybody is humbled by the problem statement that somebody else is solving also, because problem statement that you might be solving is very trivial to some person, might be, because might be there is a bigger problem that they are trying to solve. Maybe there's a whole list of complexity that they are dealing with. We are humbled by the fact that there are advanced research happening in the world today. So now, when I feel that there is a production environment which doesn't recommend a system, there's a production environment which is doing personalization. So today when I see that, there's an abrupt shift that I've seen in that experience that I'm talking today. Like, it's something like everybody knows what my next move is. Something as good as that. I want to know, are we architecting those kind of a system the right way? Because we're now talking personalization, because we are
Yeah.
now talking person specific, not herd specific or a people specific. We are talking person specific, and
Yeah.
it's personalized for you. And now when I see production issues that are like 5 years before and today, there is a number of tools to keep your system up and running for 99.99%. That's the uptime that you can really achieve today, like to the way in which we are coming with the tool sets, this, that. So what is it all about when we are architecting such kind of a system? What is the need of the hour today? Because we have not yet addressed the fact that neural networks takes a huge set of compute, and but yet we are now trying to personalize using the same amount of compute that we had back then. So are we architecting it the right way?
Definitely, definitely. We have moved towards lower computes, so and better computes even on like smaller devices, right? So like right now, Google's Pixel comes with a tensor unit. So they also realized, and most of the companies have realized that even on mobile devices, you need better compute for better experience. So the hardware is evolving. It's not that we are still behind in compute or we do need massive servers to run stuff. People have started exploring a lot in federated learning, on device learning, all those sorts of topics. And those who do work in that field, they are doing a great job. So there are all these optimizations which I talked about previously, right? So if you are a specialist in the field, you know that even that black box model can be pruned, that black box model can be reduced, and there are always trade-offs of accuracy versus performance. So people do realize these things and they are building such systems. But it's imperative that initially for a certain case, which is very intensive, compute intensive, we still have to rely on making them as an API, or like you just have them as a service. For example, OpenAI has just given their GPT-3 model as an API. You can't have that big of a model to like optimize to a certain extent that it works on your mobile devices or a CPU inference. Maybe after a few years, it might be possible. People might optimize it to such an extent, but there are always these lag from what research comes in versus what gets into production. So, like when you said that where are we moving, right? Are we moving in the right direction? So we are moving in the right direction because our focus in the industry also shifted. So previously, your major traffic came from your laptops, your bigger devices. Now everything comes from your mobile device. So mobile has become too important in day-to-day life to like have your product presence, and you can't have like longer wait times on your mobile devices, because even on your bigger laptops and workstations, sometimes it would be fine to wait for 5 seconds, 10 seconds. But on your mobile devices, your attention span is so low that even if it takes 2 seconds, you feel that this experience is not good. So the development is driven by your user experience, by everything, and that has helped people in optimizing in the right way as well. So uh, we are building systems which are like more, so it is more of an engineering problem. It again goes back to how you architect your system versus the use of AI. So people do realize that some things can be solved using your normal logic. So let's use normal logic in some cases versus have like a switch system that if a certain thing is triggered, then only you go back, fall back to a higher compute. And again, on the back end, you have nice scalable systems now, which also like run up. So that goes a lot into the DevOps side of it. But practically, that is also over optimized in a bit. And using AI is not that problematic, or even though if you don't understand auto scaling and all those things, it's probably best that you just keep it on and your system will always be in a better mode. So yeah, for some things we are doing good. For some things, definitely it will take time. So the it again depends on how a company sees a product. So if your end product is just an API which is getting consumed, uh, so it's fine to build a big compute system around it, charge accordingly. Versus if your product is just a filter which has to work on your local device, make your face look different, then you have to take a call that either that AI system makes it better, or your traditional computer vision system, your image processing systems are better, and you take that different call. And if you can have a blended model, you do that. So people are doing good job in this particular field, and because it's a pure software development, right? This has nothing to do with how sometimes AI works. It is more like how you architect your whole system, and people are good at that. People have been doing it for decades, so they have that knowledge of how to run things on local. And the best example is Google Keyboard for this. Like you have your whole speech to text models running on your Google Keyboard now versus when they used to run on API based systems long back. So pe- people do realize that the devices have changed, the systems also need to change, and AI also adapts to it. And the hardware is now catching up. So there is no more Moore's law in certain cases. So the hardware is also going in the same direction. So I think as a whole ecosystem, everyone realizes that if compute becomes a bottleneck, it gets solved rapidly. And that is what is like driving all these applications into place as well, right? I remember there was this one uh, application which used to do this neural style transfer. If you remember 2 3 years ago, that you put an image, it would do this kind of it would convert it into a painting or something. And how it would work is you upload an image, you wait for 20 seconds, 40 seconds, sometimes a minute. It would keep on loading. It would say it is put your image in a queue, and you would get response sometime back. Versus now, that thing can be done in just mere seconds, and it can be done locally. So we have definitely evolved, and we are evolving in the right direction. So it's also driven by the fact that most of the users are also now on smaller devices. So that has like a good impact on people reducing that overall footprint of the whole AI system.
I want to ask you this one question because you have been in the industry for a while and you have seen different problem statements. So now I want to ask you this one question because like there are some canonical problems where yet to be solved in the industry. There is a lot of hype about it, but nobody is touching that. So what is it all about when we speak about the unsolved problems in the industry? Because they still remain, they still prevail in all the systems that we are talking in terms of security, in terms of encryption. There is a lot of things that we need to cover. So what are some of the canonical problems that are yet to be solved? And also, can you also point out to some of the key factors which really change the way that we are architecting these kind of hefty lift and shift system today? Because back then serverless was the king. Now serverless is in the ML, and oh god, like I don't know, where are we evolving towards? I think not Microsoft, AWS came up with VMs for serverless, that is Firecracker from their architecture. And I was like, man, this is so good. Anybody needs to work on this. And I just want your views on these because, like, most of the times when we have some kind of a problem statement and yet we have some features, we don't try to make a mix and match out of it. We just
Yep.
say, okay, let's just wait for it to evolve a little bit. So, what are some of the canonical problem statements that are yet to be solved? And also, any recent trends that you saw that is really changing the way that we are architecting our solution for this hefty system?
Yeah. So as I mentioned before, like explainability is still a problem. So uh, in most of the cases, sometimes people like the end user doesn't want that explanation. So that's also fine that you don't think of building that thing at all. Versus sometimes you think that, okay, why is this particular thing happening? I want to know. Uh, that only happens when the end user, something wrong goes and they want to understand the root cause behind it. So those are still problems which people do try to solve, but they are not easy. As I said, not every model can be explained, not everything which is happening can be like understood from a human perspective. So the best example is your standard chess engines, right? So your deep blues and computers before, uh, even though they were at a certain level, after a certain point of time, better systems kept on coming. And right now, the systems which are there, they are much more advanced than human players. So some of the decisions which they take uh, are still not explainable by your top grandmasters or your top uh, chess like folks of all time, because they also don't understand why this certain thing makes sense. And the computer doesn't tell you why it makes sense. It just gives you those moves, and you see that, okay, this is the pattern, or this is a particular strategy which works. And that is problematic because on a problem level itself, chess has innumerable permutations and combinations, right? So we can also not justify at time that why was this the right decision. There may be some other way to counter it. There may be some other thing which we might be missing. There may be sometimes something which is the machine might also be missing because it also hasn't figured out all the possible compute. So that is your age old problem, which is like your explosion of permutations and combinations. So I think that's a standard computer science problem, your NP hard problems, right? So you do run into those kind of situations also in AI, that you are building a system which has infinite possibilities. So it's difficult to like try to have like a closed system. You can try to define its boundaries that, okay, it will run in these and these certain scenarios only. But if you go beyond it, it starts to break. So they will always remain. I don't think uh, we will be able to solve them in near future. It will again take time. or like a different approach itself. Maybe neural networks might not be a good thing. Maybe supervised learning is not good. So people like right now in the industry are moving more towards semi-supervised learning and these other form of uh, approaches, just because of this, that in real world, in real scenario, you don't get labeled data, right? It's difficult to get labeled data which is accurate. So like as we discussed, it comes with its human bias, it comes with tons of different things as well. So that label which is there, you also don't know is it correct or not. Even though it might be done by human, that authenticity is still debatable. So, but as a kid, when you tell someone that, okay, this is an apple, which is red, and this is an orange, which is round. So if you give them a ball, which looks like an orange, they would understand that it's an orange, but they would bounce it and see, okay, if it flops and doesn't bounce, it's a fruit. If it jumps and comes back to you, it's a ball. You don't need to tell that to a kid. They just do it by their own and understand it. So these kind of phenomenon are like driven by very less data. So currently the field is moving more towards these kind of like one-shot learning, single-shot learning models, which require less data and they understand the system, or like these global models or like universal models, which have a knowledge of their own, and then they try to build on top of it. So I think even with GPT-3 and these kind of models, that is what people are trying to solve. That you can train something which has knowledge of everything and anything, and then you can tell them that, okay, I need some information in medicine. Can I train you on this particular data so that you know this, and also have like a common sense and general sense? So those kind of system people are trying to build now, because that is again going to the main goal of having general intelligence. So it's a good step, because having general models is tricky, but it does, if cracked, solves your major problems, because one thing can be used in different use cases. So it definitely helps in like building once using n times. So that is something which is also hard. Like it's not something which everyone can build, but it is still going on. So the it's good that people are doing it. And I missed your other question. So what was that?
Any recent trends that really disrupted the way that we are architecting these kind of systems today?
Oh yeah. So again, taking the example of GPT-3 itself. So OpenAI last year came up with this whole model, right? And they put it in a very closed beta. So not everyone got that access. So that that was consciously taken as a decision because of two things. One was that like its accuracy and its inferences were much like better than what its predecessors had, and they were afraid that people might misuse it. And that was a fair kind of estimation which they had. Second was that it used massive compute. So to give it out for free or like to give access to everyone, that would again abuse a lot of their resources, right? So they took a conscious decision of keeping it in beta, soft rolling it, had that strategy of uh, only accepting people who are with genuine use cases to use it. So these kind of approaches have become common in research, especially in if you are doing these kind of uh, like products. If you are building these kind of products which are not for the masses, right? You want them to be used by a selected few. So people have taken that conscious shift, and that architecture has changed. Your traditional way of how you deploy things has changed. And I think that has also triggered a new trend, that secrecy has become like again better, right? Because they also didn't open source their model, or they didn't put out what was there. The paper was there, the code wasn't. So people did came up with their replica. So you had its open source version, but again, it wasn't trained on that much level of machine, or like that much amount can't be done because you don't have that much resources. So that trend I'm seeing of late happen a lot, and uh, that is again going back to your closed system loop, that you are not deliberately putting out stuff, uh, either because you are afraid or either because you have put so much money. If you just do it out for free, it would like not be beneficial to you. So I think closed loop systems are also coming back, which also is good for security purposes, because if you don't know, you can't crack it. But once you know, definitely it has its pros and cons, right? So if something is open source, uh, you find vulnerabilities better and faster, and they get solved quicker, versus if it is a closed system, you don't have that many eyes looking on it. So it's again a trade-off, and that is happening a lot with these kind of bigger models and hush hush research that doesn't see the light of day, uh, especially in the community.
Yeah, that's true. That's true. Institutions like Microsoft, Google, Facebook, IBM, Amazon, they are now moving towards that edge interface. Like something like, what if our systems are not capable of delivering that network bandwidth? Like recently we had a physical layer outage as well. So it really shook the world for a while, because like world had never seen that in the internet era. Like something like, okay, website going down was so common that okay, we were never able to scale, we were never able to do this, because something like Big Billion Day used to just turn off everything. Or something like World Cup used to turn off that website which used to give that ticketing and things like that. So now we are in an institution where people are against and are relying on such kind of a system. Like
Yep.
people still have that hype in their mind, but yet they are against that hype that we are trying to create, because PhDs in AI don't really think that AI will rule the world. But because I too generally feel that I've seen people ruling the world, but I don't see an AI system ruling it in the next fashionable way, like whatever it can be. Like what if it can be flawed over a course of time? What if it can be hacked? So now what is it all about when we are thinking of an AI system? Should it be a part of a PPT, or else what is it all about when you're talking about a production ready system and then human like system that is interacting with a human experience that is going to change when we add an AI to any of the product that we are coming up with? So startups are coming up with it. So what is it all about when we are advocating the right amount of AI for the world tomorrow?
So definitely you can't get all technical when you are explaining to the masses, right? You can't go down to the math. So if you have looked at product launches of Tesla or all, Google for that matter, Google also has every year they have this Google I/O where they keep on launching. AWS has AWS reInvent and other events. So those events, if you see the product launches, they constantly launch AI products. It's not that they haven't been doing that, but those are very, very people friendly, that they don't dive directly into like what is the nitty-gritties and all those things. They tell you, they try to explain stuff in a very layman term. So AI on PPT is still relevant because it needs to have a story, right? Unless it has a story, people won't relate to it. Uh, so it again depends on your target audience, right? So if you have built, let's say, a tool for developers in the AI space, then it makes sense to be more technical. It makes sense to be out there that, hey, this has this particular feature. How was this built? This was a vulnerability, so on and so forth. So one versus like if you have built a no code tool for AI. So there you can't go on explaining stuff that, okay, under the hood, this is happening, uh, this is how we coded this particular feature, uh, because it defeats its purpose. It's a no code tool. They just want you to explain how it works and what are its capabilities. So I think we have evolved into that stage where that balance is there. So if you are doing a sales, if you are doing a marketing, for your product, AI, people take it with a pinch of salt. It's not that they are amazed by looking AI out there. They know what it is capable because of all the outreach, all the courses, whatever is out there. There has become that layer of thickness in people taking data science and all these things with a pinch of salt. And and it's good because if you don't question things, uh, it becomes problematic because after you deep dive into it, you realize that, okay, this was not what was promised. So people have become aware, and people use those terms also now with caution. They don't throw it as easily as before we used to. So that is the good part. The bad part is, I would still say, the documentation around uh, certain code or like certain products. So, for example, your core products of TensorFlow, your core products, your frameworks of AWS and other places, there are code samples, there are examples, but that documentation is still not that friendly. So, those kind of things, especially on technical front, still need a lot of work. There are certain things which are done really well, and there are certain black holes where you have to go look at the code, and that code is also not understandable. There is no documentation around how to use an API, how to do these stuff. And those are the things which actually should be a focus when you're building also these kind of stuff. But as I said, everyone is like running around, right? The new framework comes around in 1 month. You have iterative updates so frequently that it's also impossible for someone to like constantly keep on updating or like making that quality content on top of it so that everyone can understand it. So developers especially find it difficult, right? Uh, it takes a lot of time for a new version to get adopted into workflows just because there isn't much information around the new version. It takes time. It takes conscious uh, failures of people to realize that, okay, this doesn't work. And then you have Stack Overflows and all the platforms which help you to practically uh, guide that and take a decision for you that don't do this right now, do it afterwards. So I think that is something which uh, we need to figure out that it for bigger like packages, for stable packages, you don't see those in like your normal JavaScript and all those other platforms. Uh, you don't have that much breaking changes, or if even if they are, they're explained in much better ways. So if people want to migrate, it that lag time is still less. Versus in AI, that lag time is phenomenal. Like I remember, there are still repos which rely on TensorFlow 0 point something, and it's difficult to port that code to current version, or like it's difficult to just convert that level to work with the recent version because there are so many fundamental changes to how that framework was. And TensorFlow 0 was just 2 years before, 2.5 years before. So it makes sense to also write these kind of back compatible things, and also to write more like have more content around these things, because these are your day-to-day problems. These are your frequent problems that people encounter, and these come under maintenance, so no one actually like gives that much importance to them. But from a developer perspective, I feel that is important. And like bigger companies do have the bandwidth to do that, but smaller companies still don't do that. So I think that is more on the culture of development which they follow, and that only trickles down into the end product which is there. So yeah.
You know, last question from my side, because a lot of folks like me who are freshers in the industry, there is always that need, like we want to learn something new and we find that gap in the space, like, hey, ML ops is coming, this is coming, that is coming, oh god, what next? And now we have companies which come up with that rules and they say that, hey, this is your designation. So what is it all about when we play with the trade-offs in a company? Like, probably a guy like me might not be good enough to be fitting inside a problem statement which does NLP, but probably if I get a problem which is very similar to what CV can be offering towards, like something can be solved using a CV, I can dig around my ways and I can start working. So what is it all about when we are trying to enter the industry and we are trying to make that new change that is required in our mindset that we are entering the world of industry, like, because it's too complex to understand what goes in and what comes out of any company. Like, startups are taking on giants, like that's the agility of startups.
Yep.
So what is it all about when we are perceiving industry for the freshers, or else for the first time when you enter the room full of people talking AI is this, what should be our mentality, and what how should we address the fact that there is a gap here, I need to fill it.
Yeah, I mean, this is also not a problem per se, like which is like because of like the job seeker, right? What has happened is that people have created so many different types of roles around the same thing, and they are called different, nothing else. So you have different types of analysts, which are very related to their particular domain. So if you are in finance, you would be a financial analyst. If you are in logistics, you would be a supply chain analyst and that sort of thing. But at the end of the day, the role is that of a data analyst. So what happens is that you might have learned all the fundamentals of data, you might have learned all your statistics, you might have learned so and so things. But when you start applying to places, they might be looking for some specific experience, or like even if they are taking on freshers, you would be trained in that specific domain. So what happens is you get confused when you are there at that time. You are like, like I'm learning this thing, which is fine for me. Uh, Now I want to go to another domain. So will that will also remain same? You think that that will remain same because the fundamentals data analysis remains the same. But some of these roles are very business driven. So unless and until you understand the business, those roles always will remain fresh to you, even if you have like 10 years of experience as a data analyst, but you don't understand finance. So even if you apply for a financial analyst role, you might find it difficult in your early days to just like sync up or like understand what is going on. So it is important also to look at companies, not just at the profile itself. So and as a fresher, you don't know actually what you want to do. So most of the time, you also uh, are like in that stage of absorbing. So you are practically thrown into whatever like particular field, and you also want to learn as much as possible. So that also works like for your campus placement. That is what happens, right? You go to a company, you are onboarded as a software engineer, and there you might be exposed to some big data engineering, there you might be exposed to some ML, and then you gradually move towards that. So that is also important, that you have to keep an open mind, uh, apply to multiple things, because the problem is that data like startups define these roles sometimes very loosely. So if there is a role of data scientist, that data scientist might end up doing more of data engineering rather than data science part of it. And they might just be writing SQL queries, they might just be cleaning data. That's it. So always take anything as a fresher, always take anything as an experience. Uh, Always understand that what that company is doing and what they are expecting out of you. And keep on exploring, right? Once you get that experience, you will know next time applying to certain place, that okay, this can be a possibility, right? That even though they say all these fancy things, at the end of the day you might be end up doing some normal thing only. So startups do come with that sort of thing, because uh, it's always understaffed, right? So they are asking you to do everything and anything. versus if you go to a very specialized role, that is very concentrated in the fact that they know what they want out of you. So that's why in those cases you also get trained in that particular field. So that's again a trade-off, right? So as I had mentioned before, you can become a generalist and you can become a specialist. So going in a generalist role sometimes helps, because at times like pandemic and recession, even if you have had random experience in just building a site, that might also help you get a job, right? Because you can still say that, hey, I have this particular experience, I know certain things which I can do. So it gives you that flexibility. Versus if you are a specialist, you can demand what you want to do. So that comes with its own power, that you know the field inside out. You know what will happen in this particular field, so you can drive those kind of conversations. So it's it both comes based on your mindset, right? Whatever you like to do. If you are a generalist, then go for your data science roles, go for very crude, simpler roles. And if you want to get into a field, if you like a field, particular company itself, then try to mold yourself in that particular thing. As a fresher, you have to mold yourself. You can't be in that state that I want to do what I want to do, because I've tried that and I understood it later on, that everything which you do in your first 3 or 4 years, even while switching from one domain to another, those are very rich in experience, which we don't realize, because we always have a perception. As a fresher, as a person who is newly moving to a field, we have formed certain perceptions about that field. And once you are in, then you realize that how right was it or how wrong was it. So it's always important to just take that plunge. Uh, but yeah, always do due diligence. Understand what the startup is doing, understand what the company is doing, and then take a call that are you comfortable doing it.
I'll just give you. Thank you so much, Parth. Thank you so much for giving such great insights. It means a lot when a person like you comes and gives us that one right touch. And I think probably that's going to help us build as what we are desiring to be. Like something like we get to know, okay, this is the reality of getting inside the industry. This is the reality of getting inside research and so on. And I think thank you so much, Parth, for giving this podcast. Means a lot when you have your own time and you just give it to us and we just get that great insights, and it was a pleasure talking to you.
Likewise, likewise. It was a pleasure being here. Thanks.